Ready? Okay, so somebody asked a good question. Milan asked, should I clear the calculator? I would say two things. If you're in the midst of writing a test, my advice to you would be, if you're the type of person that can deal with a lot of information in multiple columns, don't clear it. Why?
So you can go back to and check your answers.
If you want to go back and check your answers, if you have more time on the test, you don't have to type in all that stuff again, right? Or you might want to just look down the list, make a small edit. If you're the kind of person that just can't handle all of that mess, then clear it, okay? I personally can deal with mess. So, and I still have room to go. So I'll probably go to stat, okay? I'll go to edit. And how many lists did they give us again? 6 lists. So I have tons of room, right? So I'm going to put my next bit of X data in L4. Yunjun, can you call them out?
0.
0.
1, 2, 3, 4, 5, 6.
Okay, we got all those in. Now, I will emphasize, obviously, this is what sucks about this stuff. If you enter data incorrectly on a test or a quiz, right, that's going to throw everything off. So do your best to painstakingly, carefully read the actual data off of your paper and enter it correctly. And, or when you're done your test or your quiz, if you can, go back and double check that the data was entered correctly. Okay, can I get the dependent data engine?
100.
100.
37. 14. 5.0. 1.8. 0.7. 0.3.
Did I enter it correctly? That look correct? Okay, first question, Hyunjun.
Create a scatter plot for this data.
Create a scatter plot. So what we want to do is, let's just double check what we have under stat plot. Do we have anything on there? No. You want to just go to number 3, or do you want to just write over number 1?
Right over number 1.
Okay, fine, let's write over number 1. So we'll go to number 1. We turn it on. This is the scatter plot option. What is our X data in though? Is it an L4?
L2 and L3.
No way, no, what are you talking about?
L4.
The X data, the independent variable is L. Okay, so X is going to be L4. L4. And where is our dependent? L5? Are you guys sure?
Yeah.
Okay, fine. I'll probably presume stat. You can, by the way, you can scroll down to 9, or you can just press the number 9. And I want to get rid of the extra lines, right? Those, where are those coming from, guys? They're coming from the equations. So if I go to y equals, if I hit that, turn that off, turn that off, turn that off. If I go back to zoom, what was it, zoom stat? There it is. Now, yes?
How do we know it's not L5, L4? Why is it L4, L5?
Because it asked me, if you go to stat plot, right, it asked me, oh, you're asking me how do I know what the dependent and independent data is? Is that what you're asking me? Read the question. We're talking about, unless you're dealing with like moving close to the speed of light, is time usually the dependent variable? Time is usually the independent variable. What do we have here? We have radiation as a function of time, right? Time is usually an independent variable, right?
So independent goes on the Y? Or X?
No, X. Standard is to put your independent variable on the horizontal axis, your dependent variable on the vertical axis, and typically you associate the variable X with independent and Y with dependent. That's the way you typically see it, okay, in most textbooks and papers. Is that clear? Independent, horizontal or X-axis, dependent, vertical or Y-axis. Okay. Okay, so here we have some kind of an exponential thing here, it looks like, right? And let me read the question, I haven't even read it. As a sample of radioactive element decays into more stable elements, the amount of, sorry, I'm reading upside down, the amount of radiation it gives off decreases. The level of radiation can be used to estimate how much of the original element remains. Here are measurements for a sample of uranium-227. So you guys know that this is one of the ways that they do dating of objects, right? Fossils, right? You guys know what isotopes are?
Yeah.
Right, it's the typically you have a number of neutrons in an atom that are reflective of its most stable form. So, you know, if I took a handful, a scoop of carbon atoms somewhere, if I could do that, one in very few of them will have one more neutron than the majority of them, okay? That will be the unstable one. Well, since it's unstable, it's going to tend to decay, okay, into another element, okay? But when it decays, it gives off radiation, right? And so one of the ways of actually dating is one of the ways to do it is to actually measure the radiation, okay, the amount of radiation coming off of the sample. That'll tell you the amount of the isotope in the sample. Another way is to actually tag or count the amount of carbon-12, okay, in a sample, and so on and so forth, okay? Because obviously the older a sample is, the more of the unstable isotope has decayed or has turned into something else, right? And therefore you'd have less radiation, because when you have an isotope turn into a more stable form, it gives off radiation. Okay, now, does it make sense that I would pick exponential in this case? It does, A, because of the shape, and B, most of you have an idea that when you're dealing with things like you know, radiation from isotopes, or even if you're dealing with things like cell division and so on and so forth, or compound interest, you're talking about an exponential function. Could you have used a quadratic model for this? Yeah, you could. Would I take marks off? Maybe. I'd be like, why'd you pick quadratic? Now, if you're dealing with gravity, quadratic would make sense. Yeah?
It says in the question, use exponential.
Oh, and if it says in the question, use exponential, then I'm definitely going to take off marks if you chose quadratic.
Are you
Okay?
going to tell us which one to pick, or do you expect us to see it?
You know what? From my perspective, to alleviate headache,
Yeah, you should.
I don't know. It depends, because there might be questions where I'm like, I don't know. Mostly yes, but I don't want to say I guarantee that, because I don't want to tie my hands.
You don't want anyone to get 100.
No, that's not what I mean. I don't want to say for sure, because I'm not.
Just give us a.
As it stands, based on what I can think of at the top of my head, yes, I'll tell you what to use. But I don't want to guarantee that, because maybe there's a type of question that I create that I haven't thought of yet, so I don't want to guarantee that. Having said that, if there's a question where I don't tell you what type of model to use, I have to be reasonable. In other words, I have to give enough information. If I'm looking for a particular model, I have to give enough information in the question that will lead you to the right one, okay? Otherwise, I'll have to accept multiple models. Okay, what was part A again? Okay, so we're done. No, we didn't. Where did it go? Oh yeah, there it is. Okay, what's part B?
Exponential regression, find the equation.
That doesn't sound like English. Use an exponential regression to find the equation for the curve of best fit. Okay, that sounds more like a sentence. Okay, so we're gonna press stat. But wait, I think, do we want diagnostic on here? We might want, but we already turned it on, right? We already turned it on. So let's press stat. Let's go to calc. And let's go down to exponential. Where is it? 0?
Yeah, 0.
Okay. Now, we got to put in our independent data first, Milad. Where's our independent data? What list?
L4.
Comma. And if we want to save the equation, and damn it, I can't even remember where.
Y4.
You want to go with Y4? We could rewrite over another one, or we could go Y4. Okay. Vars, Y vars, Y4. Enter. Okay. So there's our exponential model. It always gives you the form of the equation. So you can see the form of the equation is y is equal to a times your base to the exponent x. You guys know that this caret means
Power to the power.
exponent x. Okay. So this says that radiation level is equal to 97.4 times 0.376 to the exponent of time, excuse me. And am I allowed to quote R for this one? No, I can only quote the coefficient of the termination, which is R squared, which is nearly 100%, right? So you would define that as an incredibly strong correlation. It's nearly a perfect correlation. Okay, what is... So, how would you... So, guys, for part A, what would your answer be for part A? What would you write for part A on your test? Copy the sketch with the dots. And what would you do for part B? You write down the equation. You'd say, I don't know, R equals, or you can write it as Y if you want. Y is equal to 97.4 times 0.376 to the X, or something, right? You just copy the equation. You don't want to use Y and X, you could use R for radiation, maybe, and T for time. Up to you. Okay, part C, what does part C say?
This is equation of the model. We already said yes.
Is it a good model? Yes, because the don't say correlation coefficient for this one, you lose marks. Because the coefficient of determination is nearly 100%. It's 99.93%, which is nearly perfect correlation, right? Basically means that the line of best fit pretty much sits bang on all of the data points. Okay, what's part D asking you?
Half-life is the time it takes for half of the sample to decay. Use the regression equation to estimate the half-life of the radium.
Could you be a little bit loud? Could you read that again louder, please?
A half-life is the time it takes for half of the sample to decay. Use the regression equation to estimate half-life of radium-227.
Okay, so we want to figure out how much time it takes for the original amount of radiation to become half of that quantity. What was the original quantity of radiation?
100.
Oh, it's his percentage, I see. So we want to know when it's 50%. So we could use Milad's method, which is the trace, or we could use the method of locking in another line at 50 and finding the intersection. I'll do the intersection method first. Go to y equals. First of all, I want to turn on y4. Oh, y4 is on. And under y5, I'm going to put in what? 50. And then I'll go second function. Well, before I do that, no, I'm going to hit graph. I want to see if I can see the... What the hell?
You press shift.
Okay, I see that one. Now, where's the other one? Is it still thinking about it? Okay, so I can see... By the way, did you see the little black... Oh, did you see the little line that was going here? That's when it was thinking. It kind of shows this little black line over there. Now, if you didn't see the intersection in your window, you'd have to play around with the window until you see it. So I'm just going to go second function, calc, intersect. Do I want y4 to be my first curve? Yes. Do I want y5 to be my second curve? Yes. Is that a good enough of guess? Sure it is, but if you don't feel comfortable, you can bring it right over there and you can go boom. And the answer is the half-life is about 0.68 hours. Right?
Yeah, that's true.
If you didn't want to do it that way, you could have pressed trace and just moved along this thing. And you would have got, you get close, so it's like not quite on 50%, and then you could do what, I don't know, pick the box. What Krish was suggesting, we can hit that. You can use the box feature that I showed you. Maybe you could go in there, hit that.
That's just extra work.
I'm just showing you all of the options that you guys have come up with. Just relax. Trace.
But sir,
Can you be quiet for a second? I can't see
You're
it.
too far. X is 6.
we can't get 0.68.
Okay.
Let's say you get it.
No, we got 6.7. You can get point.
Yeah.
I'm looking for 50, right?
Look. 50.
Why
So it's
isn't it,
inaccurate.
why isn't it
We're
moving?
going along the x-axis, but you're going at x equals 22.
Yeah, remove it. Look.
What was the answer again?
So go down,
X.
go down, go
Oh,
down.
it's below 1.
Okay.
Sorry, hang on a second. I want the y value to be 50, right?
X
Okay,
is
look.
So then, can you
Like
please be
this.
quiet for a second?
Over here,
so
y always equals 50,
I want,
but
so if my y value is too high, I need to move to the right, correct?
Go right.
But I zoom
Down
to
to the left, sir.
Down, go down.
Yeah, but right takes you down.
No.
No,
Oh, why is it moving on the? Oh, it's moving. It's doing the box.
There you go.
No. That's the problem. It wasn't on trace. I don't know. I don't get it.
So press up.
I already did it. I got the answer. I'm done. No, I'm done. I'm done. I already got my answer using it.
You couldn't see the
I'm done.
line.
I'm
The line
done.
was too thick.
I'm done. I got the answer. I got the intersection of the two, and I was finished a long time ago, right? Good. Forget the second method. Okay, next. What's the next part? The next part.
There's no next part.
That was it?
Yeah.
Done.
Okay, you want to do one more that might be a little different? I remember one in the book that I liked more. Where is it? I like question number 9 on page 194. I remember this question. I like it. For a few reasons. So read that one.
Okay, say that again.
I have so much stuff on this calculator now, and I'm going to clear it. It's just like, so
Question what? Question 9?
we're going to go to question number what?
Question 9?
Wait, can you say
Question number 9 on page 194.
I have to see it.
Read that one and see what happens. I'll let you struggle
Can I
through
ask-
it.
Sir, can I ask you a question? How can I save the data? Like, I didn't get it. It's so obvious.
Excuse me, save which data?
No, like the one that did for the previous question.
What do you mean save it? When you press-
Equation?
Yeah.
You're talking about the equation?
Yeah. On.
You're talking about the regression equation, or?
No. I just have to go back and like put the.
It doesn't erase. When you press stat and you press 1, look, it's all there.
Yeah, I just have to move to the next.
Yeah, it's all there. But I wanted to clear that. Shouldn't it have cleared that already?
I use a default in theorem.
Did I not clear it?
No theorem.
I didn't clear the RAM?
No.
No.
7. Oh, 1, 2. There. You may want to stop this. Whoa. And you probably would have to make a note. You'd have to say note where x, where
Zero?
your data is starting, where a value of x equals 5 corresponds to your 1995, x equals 6, just to give the reader an idea of what, because we've changed the number, right? We didn't put in 1995. Okay, what's the next part of the question?
Suppose that 100 million of
Yeah, whatever.
that preys on the insects are imported from overseas in 1995. Assuming the whatever population doubles every year, estimate when it would equal 10% of the insect population.
Okay, now I know what's going to happen here. This is going to take me too long to explain to you guys. Right now, some of you are going to understand it immediately, some of you aren't. So what I think we'll do is, because we only have
5 minutes.
and you got to put the desk back in the calculator. So what we'll do is we'll come back tomorrow. Those of you who want, you're going to give it to Jamie or somebody to put up on the computer or on the internet, the virtual one. So if you want to practice, you can get a virtual calculator tonight online somehow. Talk to each other and figure out how to do that. And we'll just put the data in tomorrow and we'll finish with this question tomorrow here, unless you try it at home.
Sure.
Yo.
Just give it to
I just give it to
Jamie, where are you going to put this so that they can see?
I'll try on Facebook.
You're going to try Facebook?
No, you can't. It's not on Facebook unless you did.
It's a download.